Hi everyone. So this video is going to continue our discussion and supplement for Module 4B, which talks about the scientific study of judgment, decision making, and reasoning. And in this particular video, I'm going to be talking about the law of large numbers. Okay, so the next question I asked you guys to answer on your worksheet was, a certain town is served by 2 hospitals. In the larger hospital, about 45 babies are born each day, and in the smaller hospital, about 15 babies are born each day. As you know, about 50% of all babies are boys. However, the exact percentage varies from day to day. Sometimes it may be higher than 50%, sometimes lower. For a period of 1 year, each hospital recorded the days on which more than 60% of the babies born were boys. Which hospital do you think recorded more such days? The larger hospital, the smaller hospital, or were they about the same? Okay, so let's take a look at this problem in more detail. So when Kahneman and Tversky asked participants this question in 1974, 22% of participants picked the large hospital, 22% of participants picked the small hospital, and 56% of participants said they were about the same, right? So presumably, most individuals assumed that both the large hospital and the small hospital would have birth rates for boys that were akin to that of the overall birth rate, or similar to that of the overall birth rate in the population, right? But as it turns out, the answer is the small hospital, right? So it's more likely that a small hospital is going to have more days where more boys are born than girls, right? So when we think about why this is the case, first we need to understand a statistical rule called the law of large numbers. So the law of large numbers basically says that the more individuals that are randomly drawn from the population, the more representative the resulting group will be of the entire population, right? So as the number of individuals that you randomly draw from the population goes up, okay, the more representative that sample is going to be of the population, right? And the inverse is also true. So as the number of individuals that you randomly draw from the population decreases, or as your sample gets smaller, it's going to be less representative of the entire population, right? So thus, in the hospital problem, it's more likely that the percentage of boys born on any given day will be near 50% in the large hospital and further away from 50% in the small hospital. Okay, so let's think about why this might be the case, right? So imagine there is a very small hospital that records only 1 birth on each day, okay? So only 1 baby gets born each day. Over a period of a year, or 365 days, okay, we have 365 births per day, with about 50% being boys and 50% being girls. However, on any given day, there will either be 100% boys being born or 100% girls, because there's only that 1 baby, right? So clearly the percentages that are observed on a single day are not going to be representative of the population and are going to be significantly higher than 50%. Okay, So that's the hospital problem.